Number 2, y equals 3x to the 4th plus 4x to the 3rd. We are trying to draw our graph. So let's look at each piece as we work our way through. So first things first, we need our first derivative test. In order to do our first derivative test, we need our first derivative. So our first derivative will look like y prime equals 12x to the 3rd plus 12x squared. So then we need to take our first derivative, set it equal to 0. I'm noticing that there's a 12x squared in common here. So I'm going to pull that out, which will give me 12x squared times x plus 1. So that means I can set each of these factors equal to 0. And then I can solve it down. So this is going to give me 0 is equal to x. And this one will give me -1 is equal to x. So that means I can complete my table for my first derivative test. That was pretty quick. Let me try that again. A little bit better. All right, here we go. So I need to split my interval twice. And this first one will be 0, and the second one will be, well, it helps if I put them in the right order. So let's make that first one -1, and the second one 0. So that means my interval here will be from -infinity to -1. And then in the middle, we have -1 to 0. And then we have 0 to infinity. All right, so now we need to test our intervals. So go ahead and pause for a minute, test our intervals and see what you get. Did you test? Did you test each interval? So if we were to pick something between -1 and -infinity, so like -2, for example, and put that back into our original first derivative, so right here, it's going to give us a negative answer. That means that we are decreasing. Pick something between -1 and 0, a little bit harder. I picked -1/2. If you put -1/2 back into our original first derivative right here, not the equation, the first derivative, it's going to be positive, which means we're increasing. Now be careful. Oftentimes there's a pattern. This one, the pattern gets thrown off. If you take 1, for example, and put it back into your original first derivative, it's going to be positive, which means increasing. Notice it didn't keep a pattern here. It stayed positive, and that's okay. It just means the graph will look a little bit different. Remember also that where you have this double sign, it's potential for something else to happen, and we'll see if something else happens in our second derivative. So now we need to figure out the other half of our coordinates. So let's see if we can find those. So we need to figure out f of -1, and we need to figure out f of 0. And remember, when we're figuring out a coordinate, that goes back into the original equation. So putting -1 in for the x in 3x to the 4th, and then plus 4 times -1, and that's to the 3rd. So back into your original equation when you're trying to find coordinates. Didn't leave myself enough space, so let me move this down. So if I solve this down, it looks like f of -1 is going to give me -1. And f of 0, that will look like 3 times 0 to the 4th plus 4 times 0 to the 3rd. And it looks like that's going to give me 0. So now I have the other half of my coordinates. So this will be -1, -1, and 0, 0. Well, there goes my nice point for 0, 0. Oh, well, at least we have some points we can put on our graph. So -1, -1 is right here. Okay, let's see if we can shrink this graph down a little bit so we can blow it back up, because we need a tiny little graph here. There we go. Is that a little better? Now you can see it. Okay, so -1, -1. Where were we? Right here. And 0, 0, right there. All right, now what do we need? We need to figure out our second derivative so we can get our concavity. And so our second derivative looks like it's going to be 36x squared plus 24x. So the second derivative, set it equal to 0. I see a common 12x. So if I pull that out, I have 12x times 3x plus 2. which means I can set 12x equal to 0, and I can set 3x plus 2 equal to 0. So then we get 0 equals x, and we get negative 2/3 equals x. So now we need to figure out our table. So this is going to be our second derivative table. So we'll need our interval, we'll need our second derivative sign, and we'll need our concavity. All right, I have 2 inflection points, which means I'm going to need to break my interval for my second derivative test twice, once at negative 2/3 and once at 0. So that means we're going to have negative infinity to negative 2/3. We're going to have negative 2/3 to 0, and we're going to have 0 to infinity. So go ahead and pause again, test each interval. Yes, it's a fraction of negative 2/3. No, that doesn't mean you have to pick a fraction. Pick a number like negative 3. Test each interval and see what you get. Did you test it into the second derivative? Did you put it back into your second derivative right here and check? For the first one, I got positive. For the middle, I got negative, and the end, I got positive, which means we are concave up, concave down, concave up. All right, so the next thing that we need to do is figure out what f of negative 2/3 is, and then we'll need f of 0 again, but we already figured that out, that's 0. So if we put negative 2/3 back into our original equation, it looks like we will get negative 16/27. And when we solve that down, we can see our concavity. So let me put our points in here. There we go. And we also didn't label over here. This will be our min. This will be, this doesn't count for doing anything. It's not a max or a min, so there's no change right there. But notice, look, where we got the 0, there is a change in concavity. So this is one where it's increasing and then it stays increasing, but the concavity changes, kind of like this picture. So we need to see what we can do to draw all this on our graph. All right, here we go. It is concave up from negative infinity to negative 2/3. Well, negative 2/3 is right about here. So it's concave up. So let's draw that. There we go. And then it switches to concave down, but it's increasing. And then it switches again to concave up at 0, but stays increasing. So concave down, concave up. There we go. That looks like the best we're going to be able to do for our graph for that one. So let's check our limits. Let's check our right and our left limits. If we're looking at the limit as x is approaching infinity, what's going to happen for this one? Looks like it's going to go to infinity. And if we're looking for our limit as x approaches negative infinity, looks like it's also going to go towards infinity for this one.